Hello, everyone, and welcome to Data Alchemy webinar series. It's great to have you here for Beyond the Data Warehouse. You're here because the data stack that felt cutting edge 3 years ago is starting to show its age in 2026. We are seeing AI workloads and BI dashboards fighting for the same resources, pipelines becoming tangled, and costs, they're creeping up. So today isn't about modernizing just to keep up with the trends. It's about showing you how to architect for this new reality without tearing down everything you've worked so hard to build. So a quick note before we dive in, because we are live, we want to answer your specific questions. You'll see a Q&A box on your screen. Please type your questions in as we go and we'll get to them at the end of the presentation. So to guide us through this, we have invited Ram Teja Yerrapothu. Ram is an architect here at Systech, and he spends his days solving exactly these kind of problems. He spent the last decade helping enterprises move away from legacy bottlenecks and onto truly scalable platforms. He knows what works in the real world and what doesn't. Ram, it's great to have you here. The floor is yours.
Thank you, Vaishnavi, for the introduction, and welcome everybody who's joining today. So let's get started. Over the next 15 to 20 minutes, what I'm going to be focusing on is how the modern data stack is evolving beyond the traditional warehouse, right? As the topic says this, and more importantly, what that would look like in a real world as we move into 2026. So this won't be theoretical. We'll look at practical modelization patterns, the common challenges that teams face, and how architecture and automation are changing the way data platforms are built and operate. So towards the end of the session, we'll have Q&A for about 10 minutes or so. Moving on to the agenda. So these are the primary areas that I'm going to focus on and get you folks clarity on, right? So we're going to focus on what the teams are actually doing in the real world. The session is designed for both technical and business leaders. So we'll keep it practical, visual, and very outcome driven. By the end of the session, you should have a clear picture of what a modern data stack looks like and why it's evolving in this way, and also how organizations are modernizing safely without disrupting their businesses. So we'll start by looking at where most of the teams start, right? So most of these organizations, this is how things look like even today. So data flows from operational systems into central warehouses, largely through batch pipelines. And if you notice the red dotted box you see in the diagram is where the traditional bottleneck lies. Historically, we had to build fragile overnight ETL jobs just to move data from point A to point B. They worked, but they were slow, manual, and expensive to maintain. As we move into 2026, the goal would be largely to eliminate these bottlenecks altogether. That's why the zero ETL patterns come in, allowing us to query or federate data directly from operational sources without managing nightly batch jobs. In legacy setups, BI, reporting, and AI often run on separate copies of the same data, with a lot of manual operations in between. This approach works, but only until scale increases, the expectations grow, and complexity starts to slow the business down. These challenges aren't specific to any particular industry. We see them pretty much everywhere. So business teams are asking for faster insights and near real-time data. So at the same time, Data teams are dealing with duplicated pipelines, duplicated data sets, and repeated rework just to keep things running. So from a leadership perspective, if you see, the costs keep going up, but the value delivered doesn't go hand in hand at the same pace. Right? So this is usually the moment organizations realize that the issue is probably not in talent or effort, but it's in the underlying architecture, which pretty much can't scale with the modern expectations. So when we say modern, we don't mean more tools or different types of technology. Modern really means a shared, well-governed data foundation that can support many use cases at the same time. So dashboards, AI models, and applications without creating duplicate pipelines or duplicate data sets. And automation is critical here. So without automation, complexity doesn't go away. It just moves probably somewhere else in the stack. So the real goal is to eventually be at a place where you do fewer manual decisions, fewer handoffs, and a platform that can scale itself as demand grows. So this use case that you see on your screen is one of the most common reasons organizations modernize. So as BI usage increases, more users run dashboards, ad hoc queries, and extracts often at the same time. On traditional platforms, everything runs on the same shared resource, so performance drops and data teams spend their time pretty much firefighting. Modern platforms solve this at the architect level, or rather the architectural level. So they separate the workloads and scale automatically so that BI users don't compete with data engineers or AI workloads. A good real-world example is Snowflake, the tool, right? So where BI ingestion and advanced analytics can run on separate compute clusters while accessing the same data. The result is predictable performance, and teams can focus on insights instead of the infrastructure. So if you also notice in the diagram in this slide, in this after section of the diagram, I've intentionally kept the setup simple in practice, but the compute can be further segmented based on user type and workload characteristics. So those familiar with Snowflake can relate to this concept. Basically, the concepts of virtual warehouses, where you can plug in different types of users to different virtual warehouses, which eventually all the virtual warehouses pick up data from the common database. So based on needs, you can play around with this combination of the compute node and the storage node, essentially. So another major shift is breaking down the wall between BI and AI altogether, right? So traditionally, ML teams build separate pipelines, but in a modern data stack, analytics and AI work off the same trusted data. So which reduces duplication and speeds the innovation. Something both leaders and engineers who really care about is this reduction in duplication and speeding in innovation. So this unified platform is where zero ETL, the term which I had used earlier as well, the magic of this zero ETL, this is where it happens. Because we can now ingest data from sources like Postgres without heavy listing. And this central layer is always fresh. So that also means that your BI dashboards, so if you see the diagram, which is towards the left, and the ML models, which is towards the right, they look at the exact same live data and no stale reports or drifting models. That's the advantage. So to give you a little bit more background about what the zero ETL or no ETL concept is, it's a fairly new and truly uh, modern activity that the industry is shifting towards. For example, Databricks is coming up with a tool of their own called Lakebase, which offers this zero ETL concept. And Snowflake, I believe, is also launching its own zero ETL capable tool. And that event might be happening as we speak parallelly as well. So this is a concept where we do not need to put efforts on building ETL pipelines, whereas these tools help us achieve that without the real need of building ETL. So that's where the whole data world is heading to. Coming to migrations, so the fear around migration is very real and common, especially when critical reports and business decisions depends on them, right? So what we consistently see is an incremental approach, but migrate in phases. We validate continuously, and we should avoid big bang cutovers wherever possible. So here is where some of the tools such as dbShift plays a key role. So dbShift basically helps you accelerate migrations from legacy platforms to modern data stacks by automating schema conversions, data movements, and reconciliations. This allows teams to run parallel systems, validate results continuously, and move forward with confidence rather than risk. Another tool which comes in handy is WizarD, which comes into play once the foundation is in place. Right? It's designed to be extremely end-user friendly. No code or deep technical knowledge is required, so business users and analysts can ask in basically simple language and still get meaningful outputs without depending on those technical or data teams for every request. So together, dbShift and WizarD reduce manual effort and speed outcomes, but they don't replace strategy. Strategy, as you know, always should come first, and automation simply makes that strategy safer, faster, and more repeatable. Most modernization failures aren't surprises. They follow similar patterns. The most common mistake organizations make is treating modernization as a hosting change instead of architectural change. They move the same designs, the same pipelines, and same dependencies into cloud and expect different results. That doesn't happen. So what actually happens is that the old bottlenecks reappear now, but only thing is that now they're running on elastic infrastructure, which often means higher costs without meaningful improvements in speed, reliability, or flexibility. The teams that succeed take a fundamentally different approach. They step back and rethink the architecture, how the data is ingested, how workloads are isolated, how governance is enforced, and how automation replaces manual effort. They also modernize in phases rather than everything at once. So starting with certain high-value workloads, validating continuously, and building confidence as they grow and as they make progress. That difference in approach is what separates simple cloud adoption from true modernization. Cloud adoption moves systems, but modernization changes how those systems work effectively. Moving on, so thinking about modernization, it can definitely feel overwhelming. So especially when organizations look at everything they want to fix at once, right? So the teams that succeed, they take, as I was mentioning, a different approach. So they don't try to modernize to entire platforms in single effort. Instead, they start small, often with one or two high-value use cases that matter most to their business. By delivering this value early, they can build confidence across both the technical teams and business stakeholders that early success which they build, it creates momentum and makes it easier to justify for the next phase, to get all the approvals and things like that. But over time, the same architectural patterns, automations, governance, they can be reused and expanded. So that's the advantage. This incremental approach, it basically reduces the risk, avoids disruption, and turns modernization into sustainable, long-term journey rather than a single time or a one-time project. Yeah. So I've come towards the end of the presentation. So to wrap it up, it's most important to recognize that modern data stacks are no longer just about warehouses, but they include ingestion, transformation, governance, analytics, and increasingly AI, all working together as a unified system. Automation is what makes the system sustainable at scale. Without automation, teams quickly hit operational limits and spend more time maintaining the pipelines rather than delivering insights. The most successful modernization journeys are not big bang transformations. They are largely iterative, outcome-driven efforts that can focus on delivering measurable business value at each and every step. So with that, I will pause over here and open it up for questions.
Ram, I think while the questions are trickling, thank you so much. I think that was very clear. What you showed, the before and after on the analytics scaling, I think that's going to resonate with a lot of people. It explains why adding more server power doesn't actually fix the architecture problem. All right, we have some great questions coming in, so let's get right to them. So Ram, the first one is a big question everyone asks, right? The audience wants to know, how is this really different from simply lifting and shifting our existing warehouse? Aren't we just moving the same data?
Right. So as I mentioned, the lift and shift, it changes where if you follow that approach, it's going to change where the warehouse is going to run, but not how it's going to work, right? If you know what I mean. So technically a modern data stack, it changes the architecture, separating the compute and the storage, and it should ideally support multiple workloads like BI and AI on the same governed data and relying on automation instead of manual tuning, right? So organizations that only lift and shift usually inherit the same performance and scalability issues that they have before, right? So that's why we shouldn't follow just that lift and shift, but think about truly changing that fundamental architecture.
Right. So it's about the architecture and not just the location.
That's right.
Great. Here's a practical one about keeping the lights on. They ask, how do you migrate to a modern stack without disrupting existing reports and business users?
That's key, right? So you already have a business set up, it's already running, and you don't want to disrupt that, right? So very valid question and very, very practical one. So as I kind of touched in my slides, so a successful modernization can be done best through a phased migration, and not like a complete changeover, right? So legacy and modern platforms, they should run in parallel with automated validation and comparison of row counts, checksums, and key business metrics. So once this confidence is established, then the workloads can be switched incrementally. By that way, you could minimize the risk and business disruptions. So that's how you should go about doing this.
All right. I think the parallel run is the safety net. Okay.
Yeah.
The next one touches on a conflict we see all the time between data science and reporting. The question is, how do you support BI and AI ML workloads together without performance conflicts?
Right. So performance conflicts comes where multiple systems or multiple workloads basically use shared compute resources, right? So what if I make a plan to separate this and give each workload its own compute resource, like the Snowflake example which I was telling you earlier in the slides, right? So you can basically separate the workloads by giving its own virtual warehouses for BI and data engineering pipelines and ML pipelines and so on. But however, utilizing the common data set beneath, right? So this ensures that BI remains responsive while analytics or ML workloads, they can scale independently, eliminating those traditional performance trade-offs. Yeah.
All right. I hope that clarifies. Okay. So the next question we have is, doesn't this kind of modern architecture increase complexity and operational overhead?
It might look more complex on paper, but it's simpler to operate in practice, in my opinion. So automation should replace many of those manual tasks. So capacity planning, performance tuning, and pipeline recovery, all of this can be accelerated by introduction of automation. So teams can spend less time managing infrastructure and more time delivering the actual data products. So which actually, if you think about it, it's going to reduce the operational overheads rather than increasing it. So, but to start with, like I was saying, it can look complex to start with, but on the long-term run, if you see, it's going to be helping you by tons. Yeah.
Okay. Thanks for taking that, Ram. We have another question. We have two more actually. Okay. So the next question that we have is, how much manual intervention is needed after AI is used? For instance, if we take months for migration and we use AI, post that, how much more manual effort is added to check or correct what AI has done? And if there is any tangible number for cost saving and effort saving?
That's a very good question. And because we keep hearing that, like wherever you log in, like even if you use your personal AI assistants, it always comes with a disclaimer saying that this is AI generated and the accuracy is not completely accurate, right? So that's a very valid question on that sense. So yes, definitely, you should get that confidence from the results, for which we do require. So it completely depends on the scale of that POC or that important workload that you are starting off with. And so if you take say 3 months to build that particular modernization activity, I would say at least a solid 2 to 3 weeks of post deployment. You would need to validate that manually and to ensure that you get that confidence out of the results. So, but there's no thumb rule to this. It completely depends on what your implementation is and how critical the responses are. So, yeah.
Great. Thanks for that, Ram. Okay, we have one more question. Right. So this is for the teams who are feeling a little overwhelmed. The question is, where should organizations start if they want to modernize their data stack?
Right. So yes, so pick an area which is of extremely high value, instead of thinking about that complete shift to modernization. Uh, and yeah, so basically modernize that one critical workload end to end, prove the value quickly, and then scale the same patterns across to other use cases. I think this is the approach which can be taken to even control risks, accelerate ROIs, and build confidence across teams. That's where we should go. That's how we should go about it.
Fantastic. I think that's a great advice to end on. Start small, prove the value. So, Ram, thank you for the insights, and to everyone watching. If you are ready to stop patching your old stack and start architecting for the future, we'd love to help. You can reach us at marketing@systecusa.com. Thank you for joining us live, and now let's get to work. Have a great day.
Thank you.
Thanks, everyone.